Google is charging you for a model you might not be getting. Let me explain. In the last few weeks, since Google rolled out expanded Gemini 2.5 Pro API access in May 2025, developers across Twitter, Reddit, and private Discords have been posting something uncomfortable. Their latency logs do not make sense. Simple prompts are returning in timeframes that are physically inconsistent with a full-weight Gemini 2.5 Pro inference pass. And the output quality on those fast responses, it looks like a distilled model, a smaller sibling, a cheaper brain wearing an expensive name tag. The villain here is not some rogue engineer. It is the economic architecture of serving trillion-parameter mixture of experts models at scale. Google, in my analysis, appears to have built a routing layer that can silently direct lower complexity queries to a lighter checkpoint, and the API contract gives them every legal right to do it. You are paying per token. The contract never promised you a specific number of active parameters per forward pass. That is the loophole, and it is enormous. Here is the proof. Point 1. Latency clustering. Independent developers running controlled benchmarks against the Gemini 2.5 Pro endpoint in late May 2025 documented bimodal latency distributions. Simple factual queries and short completions cluster around response times roughly 40 to 50% faster than complex reasoning or long context tasks. In a standard dense transformer, inference time scales relatively predictably with output length. But these clusters persist even when controlling for output token count. That pattern is consistent with two different model sizes serving behind one endpoint. The inference compute is visibly different. Point 2. Perplexity signatures. When you run the same prompt through a large model and a smaller distilled variant, the output probability distributions differ in predictable ways. Several researchers have reported that Gemini 2.5 Pro outputs on simple queries show entropy patterns more consistent with smaller parameter counts. The answers are correct, sure, but the confidence curves and token selection patterns look like a model that learned from the big one rather than the big one itself. This is textbook knowledge distillation behavior. Point 3. The economic math demands it. Serving a model with reportedly over 1 trillion total parameters across its expert layers costs real money on every single forward pass. If Google can identify that 80% of API calls are simple enough for a distilled model running at a fraction of the compute, and route only the hard queries to the full model, they save billions in annual GPU costs. The incentive is not subtle. It is survival-grade margin optimization. Every cloud AI provider faces this exact pressure. Google just appears to be acting on it first. If this kind of analysis is what you actually need to hear instead of another breathless product launch recap, subscribe. We are going deeper on this, and the industry is only getting less transparent from here. Now, the counterargument. Some will say this is just mixture of experts working as intended. In an MOE architecture, not every expert activates on every token. Simpler queries naturally activate fewer experts, so faster responses are expected, not suspicious. That is technically true. But there is a difference between fewer experts activating within the same model and routing the entire request to a fundamentally different, smaller model checkpoint. The latency gaps developers are reporting go beyond normal expert sparsity variation. We are talking about response time differences that suggest different model binaries, not just different activation patterns within one binary. And Google has published no documentation clarifying which scenario is happening. That silence is a choice. So here is where we land. The era of trusting API providers to deliver exactly the model they advertise is already over. It may have never existed. The contracts are written to give providers maximum flexibility. The inference infrastructure is built to optimize cost, not transparency. And developers building products on top of these endpoints have essentially zero auditing tools. You cannot inspect the weights. You cannot verify parameter counts. You are trusting a brand name on a dashboard. Google may be doing nothing wrong here, or they may be running one of the largest quiet bait-hand switches in cloud AI history. Either way, the fact that we cannot tell the difference is the actual problem. So I will ask you directly. Should API providers be required to disclose when they route your request to a different model than the one you selected? Or is that just the cost of doing business at scale?